In this video we will find where two curves intersect and then also find the angle between the curves at the point of intersection. So first in part A, just find where the curves intersect. So the easiest way to think about this is that if the two curves intersect in a point, then the x-coordinates at that point have to be the same, the y-coordinates have to be the same, and the z-coordinates have to be the same, because after all, it's the same point. So this gives us a system of three equations. The x-coordinates must be the same, the y-coordinates must be the same, and the z-coordinates must be the same. So, in part A, this says t squared minus 5t plus 1 equals 13 minus s squared. That's the first equation saying that where they intersect the x-coordinates are the same. The second equation that we get is 4t minus 9 equals 3s minus 5. That's just saying that where they intersect they have to have the same y-coordinate. And similarly, looking at the z-coordinates, 2 minus t has to be equal to s minus 6. So we have this system of three algebraic equations, and if we can solve this to get the proper values of s and t, that will give us the answer for part A. Now maybe let's work from the bottom up, because as you can see the z component has the simplest form, and then the y-coordinate and finally the x-coordinates look the most complicated. So let's maybe try to do the easiest thing first. So looking at the orange equation for the z-coordinates, 2 minus t is s minus 6. Let's solve this for s. So just add 6 to the other side. S is 8 minus t. Okay, that was easy. But that we don't have the answer yet. Now let's plug that in to the second equation, the green one, for the y-coordinates. And what does that do? If we do this, we get 4t minus 9 equals 3s, but s is 8 minus t minus 5. And if we multiply that out, 3 times 8 is 24, minus 5 is 19, minus 3t. So now let's ignore the middle. This says 4t minus 9 is 19 minus 3t. Now shuffle things around, move the t's to the left. 7t equals, add 9 to both sides, equals 28. Finally divide by 7 to get t equals 4. So this is our answer. T equals 4. And above, remember, we said s is 8 minus t. So if t is 4, then s is 8 minus 4, which also happens to be 4. So it didn't necessarily have to happen that the s and t values were the same, but coincidentally in this case, that's what happened. So the point where they intersect, so this is our answer to part A. The point where they intersect is the point where t equals 4 on the first curve and s equals 4 on the second curve. Okay, so that does it for part A. For part B, we have to find the angle between the curves at that point. So by definition, what does that mean? The angle between two curves at a point where they intersect is defined to be the angle between their tangent vectors. And remember, the tangent vector is just the same thing as the derivative. So if we take r1 prime of t and r2 prime of s, Those are the tangent vectors. So let's do that. So what's R1 prime? Well, R1 prime is 2t minus 5 for the first slot, and then 4 and minus 1. Now for the second one, R2 prime is minus 2s, 3, and 1. Okay, that's in general. We want to find those tangent vectors at that particular intersection point. Meaning we need to plug in 4 for t in the first one and 4 for s in the second one. So R1 prime of 4 is 2 times 4 is 8 minus 5 is 3. And then these are just constants, they don't involve t. And again, plug in s equals 4 in the second one. Minus 2 times 4 is minus 8, and then these are constants, they don't depend on s. So here are our two tangent vectors. Now finally we just need to find the angle between these two vectors, and that will be our answer. Now we have to think back to when we studied the dot product to remember how to find the angle between two vectors. Remember, in general, if we call theta the angle that we're looking for, the cosine of that angle is equal to the dot product of the two vectors divided by the product of their lengths. So let's compute that. Let's see, what's the dot product? 3 times negative 8 is negative 24. Plus 4 times 3, so plus 12 is negative 12. And then minus 1, so negative 13 is the dot product. Divided by the product of their lengths. So just compute the lengths of these two vectors and you'll see that they are square root of 26 and square root of 74. And unfortunately this isn't one of those nice numbers where we know what the angle is going to be. So we can't really say much other than the angle is the arc cosine of this ugly number that we just got. And we just sort of have to be happy with this. It's not going to get any simpler looking. So this is our answer. This is the angle between the tangent vectors, which is defined to be the angle between the curves themselves.